Question 1. Find the number of lines of symmetry for each of the following shapes. So these are the shapes for which we have to find the number of lines of symmetry. So first of all, let's see A part. So a line of symmetry is something if you place mirror on that, you get the opposite figure of that. So we have 1, 2, 3, 4 lines of symmetry for A part. So this was the A part. Now B part. So this is the figure, these round figures. So if we place line of symmetry vertical, we will be able to make it diagonally. We will also be able to have the pattern on the other side. So total we have 1, 2, 3, 4 line of symmetry. Now C part. Now this is the plus. Pictorially represented. So here again we have 1, 2, 3 and 4 possible lines of symmetry. Now this toy has only one line of symmetry, that is vertical, that is his eyes and mouths are separated with it. Now this is a 1, 2, 3, 4, 5, 6 hexagon. A regular hexagon has 6 lines of symmetries. So 1, 2, 3, 4, 5, 6. So if you place mirror on each line of symmetry, you'll be able to get the other side. Now F part, this is again the same thing. Again we have 6 line of symmetries because the inside figure in this hexagon is also symmetrical. Now here G part has no symmetry. If you make a vertical line, you will not be able to get the following figure on the other side. So line of symmetry is just flipping the object across the line. Now this was the G part, it has no line of symmetry. H part, so this symbol has also no line of symmetry. If you try to place in any side, you will not be able to get the inverted side of the following diagram. Now I part, this petal of a flower has 3 line of symmetry. So you will be able to get the other side flipped if you place your mirror on any of these sides. This was your first question. Second, copy the triangle in each of the following figures on squared paper. In each case, draw the lines of symmetry, if any, and identify the type of triangle. Some of you may like to trace the figure and try paper folding first. So we will do in this question itself because it is already placed on the square paper. So you can see it is an isosceles triangle because only these sides are equal, 1, 2, 3, 4, 5, 6, and again 1, 2, 3, 4, 5, 6. So this is an isosceles triangle. So isosceles triangles have only one line of symmetry, that is vertical, going from the top vertex to the between of the other side. That was your A part, only having one line of symmetry. Now B part, this is an equilateral triangle. If you count this side, 1, 2, 3, 4, 5, 6, 1, 2, 3, 4, 5, 6, and again 1, 2, 3, 4, 5, 6. Equilateral triangle has 3 lines of symmetry. You have to remember this. So if you place in any of these 3 line of symmetries the mirror, you will be able to get the other side. triangle. Make sure it passes from one vertex and goes from the opposite side in between. So this was your 3 line of symmetries you will make for your equilateral triangle. That was your B part. Now see, this is a right angle triangle. Here it is right angle, and it has again one line of symmetry. No other possible line of symmetry in case of right angle triangle. So D part, it is again an isosceles triangle, just tilted towards the side. So as for the case of A part, it has also one line of symmetry passing through this vertex and going to the other side from between. This was your D part, question number 2. Question 3rd. Complete the following table. So shape, rough figure and number of line of symmetry are depicted here. First one is given, equilateral triangle. As we have studied, it has 3 line of symmetries as shown in the figure. So we write 3 for it. Similarly, we will do for square. Well, this is your square. So square has 4 line of symmetries as represented here. So 1, 2, 3, 4. Therefore, we write square has number of line of symmetry equals to 4. Now for rectangle. So this is your rectangle having 2 opposite sides equal in length. So it has 2 number of lines of symmetry. Now isosceles triangle, we have studied earlier as well in the previous question. It has only 1 line of symmetry. Therefore we write 1 in place of number of lines of symmetry. Now rhombus. So this is your rhombus. It has again 2 lines of symmetry. So writing 2 on the place of number of lines of symmetry. Now circle. Well, this is your circle. When you try to make number of lines of symmetry for circle, they turn out to be infinite. That was your question 3rd. 4th. Can you draw a triangle which has A part exactly 1 line of symmetry? Yes, obviously, isosceles triangle we have studied in previous 2 questions. Exactly 1 line of symmetry in case of isosceles triangle. Exactly 2 lines of symmetry? Well, there is no triangle possible to have 2 lines of symmetry. 3 lines of symmetry? Well, yes, equilateral, we have studied it. So we can make from all the 3 vertices and going from the other opposite side from between. So these are the 3 lines of symmetry in case of equilateral triangle. No lines of symmetry? Well, yes, obviously, scalene triangle. Scalene triangle is one which do not have any sides equal. So this was your question 4. 5. On a square paper, sketch the following. A triangle with a horizontal line of symmetry but no vertical line of symmetry. So we have constructed a triangle which has only horizontal line of symmetry. As you can see here, if you flip on the horizontal direction, you will be able to get the triangle. A quadrilateral of both horizontal and vertical line of symmetry. Well, yes, this is a rectangle. We have studied rectangle has both horizontal and vertical lines of symmetry. Now C part, quadrilateral with horizontal line of symmetry but no vertical line of symmetry. Well, yes, you can make it. Keep one side longer and other side shorter you'll be able to make it with horizontal line of symmetry, as we have shown in this case. There is no vertical line of symmetry for C part. D. A hexagon with exactly 2 lines of symmetry. Well, obviously yes, D part has. As you can see here, just don't make it a regular hexagon. Keep one side longer than the other. You'll be able to make hexagon with exactly 2 lines of symmetry. E part, hexagon with 6 lines of symmetry. Well, yes, you can make it. Just make the regular hexagon having all the sides equal. It has 6 lines of symmetry. As you can see here in this picture. So that was your E part of the question number 5. Sixth, trace each figure and draw the lines of symmetry, if any. Well, A part. It is an equilateral triangle, but we cannot make any line of symmetry. Why? Because it has some sides which will not be able to deflect when we make the line of symmetries. B part, well, it is very easy. It has 2 line of symmetries. You'll be able to get a reflection of 1 if you place on any of these line of symmetries. So this is a square. As you have read earlier, square has 4 line of symmetries, therefore it has 4. Now this is irregular hexagon. As we have studied earlier, it has both vertical and horizontal line of symmetries. This is a kite, so it has only 1 line of symmetry, the horizontal line of symmetry. This figure has 4 line of symmetries. You'll be able to get other part or the reflected part if you place a mirror on any of these line of symmetries. That was the whole purpose of making line of symmetries. Question 7. Consider the letters of English alphabets A to Z. List among them the letters which have A part vertical line of symmetry like A. Well, you can see here A has vertical line of symmetry, and then we have H. H has both. I also has. M also has. O also has. We have T as well. Q has also vertical line of symmetry. V including. W also has. X also has, and Y also has. So these are the letters that have vertical line of symmetry. Now horizontal line of symmetry like B. So as you can see, B, C, D, E, H. H was having both. Then you have K, then X, then you have O. Okay, so these are horizontal lines of symmetry. Alphabets. Now no lines of symmetry. There are some letters which do not have any line of symmetry like F, G, J, L, N, P, Q, R, S, and Z. These letters have no lines of symmetry at all. So that was your last question, question number 7. 8th. Given here are figures of a few folded sheets and designs drawn about the fold. So this is the paper, this has been folded and design has been made. In each case, draw a rough diagram. In every case, you have to draw a rough diagram to complete figure that would be seen when the design is cut off. So you have to first make the design and you have to cut it with the help of scissor or any gadget for that purpose. When you open that, what kind of pattern you will get. So first part is shown. This was the vertical line of symmetry. So similar figure will be created. Now B part, when this paper will be flipped downwards, so you will get such type of cutted portion. So this was simple. Both questions were simple. You can use it practically. You can do it practically. So this was your last question, question number 8.